Yeah, good afternoon, everyone. Good afternoon, students. Welcome, everyone. So, students, before starting today's lecture, please let me know quickly in the chat box. Am I audible? The voice is clear or not? And the screen is visible or not? Just let me know quickly in the chat box. These two simple questions. Am I audible? And the screen is visible? Yes or no? Quickly. So that we can start with today's lecture, everyone. Yes. Clear, everyone? Hello. Hello, Kripa. Okay. Very good. Very good. So, students, uh, in today's class, what we are going to do is we are going to start a new chapter called limits. Okay. So, in the last class, we have finished our discussion on the sequence series. Yes or no? I hope everybody have now gotten the good idea about the sequence series AP, GP, HP, and all the different series, right? Similarly, the limits is also very easy chapter like the sequence series. Okay. So today we are going to have the little in basic introduction on the limits. Okay, just what is the limit, how to find the limit, all those things we will be doing in the next class. But today our main agenda is to find, just be the comfortable with the concept of limit. Actually, what is the limit and how, where we use the limit, and what is the significance of using the limit. All those things we will be having discussion today. Is this clear, everyone? Okay. So students, first of all, yeah, tell me first thing. So as I told you, so we will be using, first we will see the introduction of the limit, then we will see something called indeterminate form, and then we will see the LHL, RHL, which is nothing but left hand limit and right hand limit. Okay, so these three things we will be covering most of the time. Okay. Okay. So students, before starting the introduction of limit, just quickly let me know. Everyone, please tell me quickly in the chat box, everyone. If I ask you what is the value of f of x at x is equal to a, can anybody tell me quickly in the chat box what is the value of f of x at x is equal to a? As you can see, the graph, this is the f of x, okay? This is the f of x. This is the graph of f of x, right? So as you can see, at x is equal to a, it is hollow, right? It means it is not taking any value, right? So what you will say, f of x at x is equal to a is not defined, right? There is no value for which it can take, yes or no? Now, if I ask you another question, okay, so the value at x is equal to a, we don't know, right? But if I ask you one more question, that if I approach x is equal to a, if I approach x is equal to a, right? Like this, right? Like this, or like this, where the value of f of x is approaching towards the L, right? Towards the L. Yes or no? Is this clear or no? So when we approach, when we approach at x is equal to a, right? Value of f of x approaches towards L. Is this clear? ये तो सबको clear होगा. Yes or no? As you are approaching towards x is equal to a, the value of f of x is approaching towards L. Is this clear? So this is the mainly idea of the limits. Okay. What happens in the limit is, sometimes the value of a function at x is equal to a is not defined, but we have to know where the value of f of x is going when I'm approaching towards the x is equal to a. So that is the idea of the limit. Is this clear, everyone? Is this clear? So that is the limit. Okay. When I'm approaching towards the x is equal to a, where my value of function is approaching. That is the questions we are going to answer in so many ways. Okay. So what is that question? The question is, where f of x is approaching when x is approaching towards x is equal to a, and there is a symbol we use, that is x tends to a. It means when x is approaching towards a, where my f of x is approaching. Okay, so that is the most important questions, and that is the only questions that we are going to answer in the limit. And there will be so many ways we will be seeing to answer this question. Is this clear, everyone? Tell me quickly in the chat box. Is this clear? Okay, so that is the limit idea. Is this clear? Any doubt so far, students? I hope this is clear now, right? Okay. So as you can see, students, there are two ways of approaching towards x is equal to a, right? From left hand side, yes or no? This is from the approaching towards left hand side, right? And this is approaching towards right hand side, right? So that's why there are two that's why there are two types of approach, left hand limit and right hand limit. Is this clear? We will come back to that later, but I just want you to be clear with the idea that how we are approaching towards x is equal to a. There are two ways, either from the left hand side or from the right hand side. Is this clear, everyone? Clear? So idea of the limit is clear. What is the limit, right? Okay, if it is clear, then let's move on to the next slide. Okay, so now we will see the definition of the limit. Okay, now we will see the definition of limit. Okay, chalo, let's start. So student, first of all, when we write like this, it means limit x tends to a, f of x is equal to L. How we say that? Limit of f of x as x approaches a equals L. It means when x is approaching towards a, my value of function, that is the limit, is approaching towards L. Is this clear? And roughly speaking, students, this says that value of f of x get closer and closer to the number capital L as x gets closer and closer to the number a. But you should know x is not equal to a. We are approaching towards a, but x is not exactly a. Is this clear, everyone? Tell me quickly in the chat box, is this clear or not? How many of you got the idea of the limit? Is this clear? Everyone, tell me quickly in the chat box. Quickly, students, let me know. Idea of the limit is clear? Okay. So, yes, very good, Kripa, very good. So, students, we will see there why we use the limit exactly. So, if I ask you, first of all, if I ask you, tell me, if I ask you 1 upon 0, what is the value of 1 upon 0? What you will say? What is the value of 1 upon 0? This is nothing but infinity. Yes or no? This is nothing but infinity. But if I ask you, tell me what is the value of 0 upon 0? This is not defined, right? This is not defined, right? And if I ask you what is the value of 0 upon 0, what you will say? Tell me, 0 upon 0. 0 upon 0. This is again not defined, but we say that this is indeterminate. Indeterminate form. Okay, what does this mean? It means 0 by 0 can take any value. Any value it can take depends upon the function. 0 by 0 sometimes when you have the situation where it is becoming 0 upon 0, it can take the value 0, or it can take the value 10, it can take the value pi, any value it can take. It just depends upon the function to function. Is this clear? So that's why we will say that 0 upon 0 is indeterminate form. We cannot determine first. Okay, we have to look at the function and then we will comment on the value of the 0 upon 0. But when we have 1 upon 0, we will directly go ahead and say that it is not defined because it takes the value infinity, right? But in some way it is determined, right? We are able to comment that it is going to take infinity or not. But 0 upon 0, we cannot even comment which value it can take. Are you getting my point? Is this clear? So like that, students, there are 7 indeterminate form where we use the limit. Okay, so where we are going to use the limit, we find the value of it by using concept of limit. Is this clear? Where we use the limit, we use the limit to find the values of indeterminate form precisely. Is this clear? So if somewhere it is creating 1 upon 0, then we don't use limit. We just directly comment that it's infinity or minus infinity. But if at some place we are making 0 upon 0, then we will say that this value will be determined after finding its limit. And in this, throughout this chapter, we will be seeing so many different techniques to find the limit. Is this clear? Okay, so as I was saying, there are 7 indeterminate form. Okay, 7 indeterminate form. Okay, so these are here. These are the 7 indeterminate form. Okay, first is 0 upon 0. Second is infinity upon infinity. Third is 0 into infinity. See, infinity upon infinity also indeterminate. 0 into infinity is also. And fourth is infinity minus infinity. 1 raised to the power infinity, 0 raised to the power 0, and infinity raised to the power 0. Okay. Value of such indeterminate form can be found using limits. Is this clear? These are the 7 indeterminate form. That's it. There are no more or less than these. These are the only 7 indeterminate form where we use the concept of limit. So whenever in a question you will find any of these 7 indeterminate form, then you will keep in mind that you have to find that value using the limit. So 0 upon 0, infinity upon infinity, 0 into infinity, infinity minus infinity, 1 raised to the power infinity, 0 raised to the power 0, infinity raised to the power 0, right? See, 0 raised to the power 0 kyun hai? Because some people will say any number raised to the power 0 is 1, right? Any number raised to the power 0 is 1. But 0 raised to the power any number is also is 0. So that's why it is indeterminate. Are you getting my point? Are you getting my point? So value of these indeterminate form can be found using limits. Is this clear? So these are the 7 indeterminate form we will be seeing throughout this chapter, and we will be seeing the different technique to tackle these indeterminate form. Am I clear, students? Tell me, is this clear? Quickly let me know in the chat box how many of you understood this. Okay, please make a note of this, take a screenshot. But these are the only 7 indeterminate form. Sometime in an exam, they ask you which of the following is not an indeterminate form. So you have to know that these are the only 7 indeterminate form. Other than that, there are no indeterminate form. Is this clear? So that's why I have added one more slide, okay, to get the idea of it. But before that, let me tell you how you will tackle this problem. Okay, so there's some example on it. First example is this. Okay, let's say it asks you to find the value of 10x minus sec x at x tend to pi by 2. So this is the way you write, right? You have to find the limit x tend to pi by 2, 10x minus sec x. So it means there is a function called 10x minus sec x, and we have to find the value of it when x is approaching toward pi by 2. So if you look closely, 10 pi by, if you put x is equal to pi by 2, what you will get? 10 pi by 2 minus sec pi by 2, which is nothing but 10 pi by 2 is infinity, sec pi by 2 is also infinity. So it is nothing but infinity minus infinity. So it means it is an indeterminate form. So directly we cannot find its value. So we have to use the concept of limit. Is this clear, everyone? Similarly, here Put x is equal to 1, what you are getting? 1 minus 3 plus 2 upon 1 minus 1, 0 upon 0, right? So it means when x is approaching toward 1, this value of the function is becoming indeterminate, approaching towards 0 upon 0 form. So that's why it is also an indeterminate form. And when limit x tend to infinity, x square minus 5x plus 6 divided by 2x square plus 4. So this is a function f of x. When x is infinity, it is becoming nothing but infinity upon infinity. So it means value of this function is also indeterminate. We have to find the value using the concept of limit. Is this clear? So all these values we will be finding after we will see the concept, techniques or strategies to find the limits. But you will keep that in mind. These type of questions will keep coming and coming because these are the indeterminate form, right? You have to find, let's say I'll give you one idea. Let's say f of x is, let's say you have f of x is 10x minus sec x, right? And somebody asks you that when x is approaching towards pi by 2, tell me where this function is approaching. So how you will find? You will find using the limit, right? When x is approaching pi by 2, where this function is approaching. Okay, so that's the answer we will be giving by seeing the techniques of limits. Okay, we will see how to find the limits, but we are making sure that we should know where to use limits and where to not use limit. Is this clear? I hope this is clear, right? Okay, so I'll give you one more example. I have added this slide especially because so many students have confusion in it. So that's why I have added this slide separately so that from today, we don't have any confusion between the not defined, non-indeterminate, right? Any non-zero value upon 0, it's towards infinity. Okay, so it means it is not a indeterminate form. Okay, that's why I'm saying it is not defined but not indeterminate form. Finite value upon 0 is tends towards infinity. We know the answer. It is tending towards infinity. It means it is already we have determined the answer, right? So that's why it is called, it is not an indeterminate form. Similarly, 0 raised to the power infinity will tend towards 0. Infinity plus infinity is infinity. Infinity into infinity is infinity. Infinity raised to the power infinity is also infinity. So these all are not indeterminate form. Is this clear? These are not indeterminate form. Indeterminate form are only 7. What are those? These. 0 upon 0, infinity upon infinity, 0 into infinity, infinity minus infinity, 1 raised to the power infinity, 0 raised to the power 0, infinity raised to the power 0. Is this clear, students? Tell me quickly in the chat box. Is this clear? Quickly let me know in the chat box. Is this clear, everyone? Any doubt so far? Any doubt, students? Tell me. Is this clear? So where the indeterminate form is there and which are the indeterminate form, which are not the indeterminate form. Is this clear? I hope this is clear to you now. Why? So, okay. Chalo. So if it is clear, so let's proceed. Now we will see the concept of left hand limit and right hand limit. So now we got the introduction of the limit. Now we are starting to find the limit actually. So for that, we will be seeing the concept of left hand limit and right hand limit. Is this clear? So when we'll say limit x tend to a, f of x is said to exist at x is equal to a if left hand limit is at x is equal to a equals to right hand limit at x is equal to a and equals to finite value. Clear? It means left hand limit at x is equal to a is equal to right hand limit at x is equal to a is equal to finite value. Okay. Is this clear? So LHL is equal to RHL is equal to finite. Okay. 1 point if I add, if any of the limit is infinity, then we simply say limit does not exist. Okay. See, it is very common sense, right? See, if, let's say at x is equal to a. See, let's say 1 second. Let's say at x is equal to a. Okay. Function is approaching, right? At x is equal to a, we are approaching the function, right? We are approaching the function, well and good. Okay. So like this. Let's say this is your function, right? This is your function. Limit at x is equal to a. What does this mean? It means when my x is approaching towards a, where my value of f of x is approaching. And it is common sense that value of function when x is approaching towards a cannot be approached towards multiple value. Yes or no? Yes or no? That's it is a function, right? So that's why if I say like this, if I say, let's say, this is x is equal to 1, for example. Okay. And this is value 1 and this is value 2. Okay. Now, student, please, everyone pay attention here. If I ask you, if we approach the function from left hand side, means from here, right? The value of function is approaching towards 1. Yes or no? Right? Yes or no? So when we approach x is equal to 1, x1 from left hand side, value of f of x approaches towards 1. But if I approach the function from the right hand side, right? From the right hand side, the value of the function is approaching towards 2. So you will say that, students, that limit x tends to 1 minus. 1 minus means I'm approaching the function at x is equal to 1 from the left hand side. F of x is equal to 1. So this is nothing but left hand limit. Clear? This is nothing but left hand limit. It means 1 minus means value of a function when I approach at x is equal to a from the left hand side. So what does a right hand side means? Right hand limit means limit x tends to 1 plus. 1 plus means I'm approaching the function from the right hand side, f of x. And kitni value of 2, right? So since it is a function, so approaching from the left hand side and the right hand side should have the same value. Yes or no? But these are not the same value. So we will simply say limit does not exist. Is this clear, students? Is this clear? So whenever I'm approaching towards from the left hand side, whenever I'm approaching towards the left hand side, I will keep a minus sign above it. And whenever I'm approaching towards the right hand side, I'll put a plus sign. Clear? I hope this is clear now. Okay. So let me write it down. So left hand limit. Left hand limit means LHL. So it is nothing but value of function. So it is f of 1 second. Yeah. So when I'll say left hand limit, it means limit x tends to a minus f of x. Clear? Is this clear? It can be given as limit x tends to a minus h, where h is tending to 0. JNV Ballari, you are asking me chapter name now. Chapter name is limits. Okay, chapter name is limits. So it means when I'm approaching x, a minus h means, see, this is what a minus h means. So this is nothing but 1 minus h, and this is nothing but 1 plus h. Okay, clear? So limit x tending to a minus h f of, where h is tending to 0, f of x. This is LHL. This is nothing but f of a minus. Similarly, right hand limit क्या होता है? Right hand limit. Right hand limit. Right hand limit definition should be clear. Okay, definition should be clear. What does right hand limit mean? The value of a function when we approach x is equal to a from the right hand side. Okay, so it means limit, x tends to a plus f of x, which is nothing but limit x tends to a plus h, where h is tending to 0, f of x. Okay, is nothing but f of a plus. Is this clear? So this is left hand limit and right hand limit. So when left hand limit and right hand limits are equal and finite, then we will say that limit exists. Is this clear, everyone? Tell me quickly in the chat box. Is this clear? Everyone, quickly let me know in the chat box. Is this clear or not? Do you have any doubt? So in today's class, we will just having the introduction. What is the limit? How to find the limit? What is the left hand limit, right hand limit? Okay, so the fundamental we are covering today. Okay, from the next class, we will see the different techniques to find the limit. Okay, but make sure, because see student, this limit chapter is very, very, very important, because in the 12th class, in most of the chapter, continuity, differentiability, the application of limit is very, very huge. So that's why we teach this limit at the end of the 11th class. Okay, okay, because the application of it, this chapter is actually is in the class 12, and it is very, very huge application. Without the limit, the calculus you can't move. Okay, so limit exists. So limit exists when right hand limit is equal to left hand limit is equal to finite value. Is this clear, everyone? Tell me quickly in the chat box. Is this clear, or do you have any doubt? Quickly let me know, everyone. Quickly. Clear? Okay. So what is the left hand limit? Right hand limit is limit h tending to 0, f of a plus h. Left hand limit is limit h tending to 0, f of a minus h. These two should be equal, and this should be equal to finite value. Okay. So when this happens, we will say that limit exists. Is this clear, everyone? Quickly let me know in the chat box. Is this clear? So whenever you have to find limit, you have to find the left hand limit and the right hand limit separately and check first whether these values are equal. First check whether these values are finite, and then check whether these values are equal. If both conditions are satisfying, then you will say limit exists. Okay. For example, if let's say something like this happened, you are first finding the left hand limit, and the left hand limit is coming infinity. Then straight ahead, you don't need to find the right hand limit. You can directly say that limit does not exist. Clear? Because the left hand limit should be finite for limit to be exist, but it is not. So that's why we will say directly limit does not exist. Is this clear, everyone? Tell me quickly in the chat box. Okay. Clear, everyone? Okay. So left hand limit and right hand limits are clear, right? left hand limit of a function f of x at x equal to a is that value of f of x which is dictated by the function value of f of x when x tends toward a from the left. Okay, clear? Similarly, right hand limit can be written like this: f of a plus h. Okay, is this clear, everyone? Is this clear? So left hand limit क्या होता है? This is the left hand limit. Limit h tends to 0 f of a minus h. Right hand limit is limit h tends to 0 f of a plus h. More like it makes sense, right? What is left hand limit? We are seeing where the value of function is approaching when I'm moving from the left to right, right? If I'm approaching the function towards from the left. So from the left, what we are seeing? A minus h, right? So if you students see, if you look closely, it will make sense. Okay, it's not very hard. See, I'll tell you once again. It's not very hard. It's very common sense actually. Okay. See, this is a function. Let's say this is a function, right? Let's say function is not defined here, and this is x is equal to a, right? And if I ask you, if I approach toward x is equal to where my function is approaching, so for that there are two ways. Either you can approach x towards a from the left hand side. So here in the immediate neighborhood, here a minus h, right? So you will find f of a minus h, yes or no? Right? So in the immediate right neighborhood, you will see the a plus h, right? So what is this value? This is limit h tends to 0 f of a minus h. What is this value? Limit h tends to 0 f of a plus h. And these are this a plus h, a minus h, since h is tending towards 0. Not that. H is tending towards 0. So these are very, very close to x is equal to a. So value should be equal. Yes or no? Are you getting my point? So that's why left hand limit and right hand limits should be equal, and left hand limit is limit h tends to 0 f of a minus h. Right hand limit is limit h tends to 0 f of a plus h. I hope this is clear now. Left hand limit क्या होता है? Right hand limit क्या होता है? Right? Limit क्या होता है? How to find the limit? Left hand limit should be equal to right hand limit should be equal to finite. Clear, everyone? Tell me quickly in the chat box how many of is this clear or not? Tell me quickly in the chat box so that we can proceed. Quickly. Everyone clear? I hope no one has any doubts. Okay, very good, Kripa, very good. Okay. So since we now know how to find the limit, just find the left hand limit, right hand limit, and check whether they are finite and they are equal. If both things are satisfying, we will say limit exists. And what is limit? The value of a function when x approaches towards a, right? So now we will solve couple of examples just to get the idea, just to be familiarized with the concept of limit. Okay. So if I ask you this question, limit x tends to 2 box of x, which is GIF. This is greatest integer function divided by x. Okay. So you have to find the limit. Okay. Since this is a first example, let me solve this. Okay. So how do you find the limit? You will first find the left hand limit, right? So what I will do, first is left hand limit. Okay. From the second example, I will be directly writing like LHL, left hand limit. What is left hand limit? Left hand limit is limit h tends to 0 f of 2 minus h, which is nothing but limit h tends to 0. What is 2 minus h? 2 means replace x with 2 minus h. So it is nothing but box of 2 minus h divided by 2 minus h. Now this is nothing but greatest integer function, and inside this greatest integer function it is 2 minus h. 2 minus h क्या होता है? means 1.999 something. Yes or no? Means this value is less than 2, right? This value is less than 2. So what you will say? It is nothing but, how much is this? Box of 2 minus h, radius integer function of 2 minus h, means it is less than 2. So which is nothing but 1 upon 2 minus h. And now, see, now it is not indeterminate form, so directly put h equal to 0. So 1 by 2. Is this clear, everyone? Is this clear? Left hand limit, how do you find? Simple, just replace x with a minus h and start solving the question. Usually, just the factorization or anything. Here, this is box of 2 minus h, right? We know that box of value where value is less than 2 is nothing but 1 only, right? 2 minus, right? So now, second is right hand limit. Second is right hand limit. Right hand limit, which is RHL. So what is, sorry, RHL? What is RHL? RHL is limit h tends to 0, f of 2 plus h, right? Which is limit h tends to 0. Now replace x with 2 plus h. So box of 2 plus h divided by 2 plus h. Now tell me quickly in the chat box, everyone. What is the box of 2 plus h? Everyone quickly. It is just a very, just immediate right number from the 2. Means this number is just slightly greater than 2. So box of number which is slightly greater than 2 is 2 only. Yes or no? 2 upon 2 plus h. So now it is not in indeterminate form. So directly put h equal to 0. 2 upon 2 which is equal to 1. Clear? Is this clear, everyone? Tell me quickly in the chat box. कितने लोगों को समझ में आ गया? Quickly. Tell me quickly in the chat box. Okay. Lamma, is this clear now? My voice is clear now? Okay. Okay, very good. Thank you, JNV Balani. So as you can see, student, left hand limit is half, right hand limit is 1, right? So since left hand limit is not equal to right hand limit, it implies limit does not exist. Clear? Clear? So now have you got the idea how to start finding the limit, right? See, this is the box of x, right? Greatest integer function. So definition of the limit should be clear. Left hand limit is limit h tends to 0, f of 2 minus h. So just replace x with 2 minus h. And now box of 2 minus h is nothing but 1 and 2 minus h as it is. So now it is no longer in indeterminate form. So put h equal to 0 and find the limit. So it means, what does this mean? It means when I approach this function from the left hand side, this value of the function is approaching towards half. And when I approach the same function from the right hand side, the value of the function is approaching towards 1. That is that. Is this clear? Is this clear? Okay. If it is clear, so shall we move? Shall we further move? Tell me quickly. Okay. So now let's do one more question on it. Okay. Okay, I'll ask you to do it. Okay. I'm giving you 1 minute, students. Please answer this question. Limit x tends to 0. This is fractional x. Okay, fractional x. Okay. I'm giving you 1 minute. Everyone start solving this question and let me know the answer. This is very easy. Since we have done the greatest integer function, so this is very easy. Everyone start doing it and let me know the answer quickly in the chat box. Start solving. Everyone tell me the answer quickly. What is the limit of limit x tends to 0 fractional x? Simple, very simple, right? Quickly let me know, everyone. You have 40 seconds now, everyone. Start solving it. Sagar is saying 0. Okay. So 0, it means which limit? Left hand limit is 0 or right hand limit is 0? Sagar, see, I have told you that you have to find the left hand limit and right hand limit separately. Like the previous question, right? So do that and tell me now. Or is this clear, everyone? Students, anybody got the answer? Sagar, what about you? So now let's start solving it, okay? First finding the, 1 second. Let's start finding, first start finding the left hand limit, then right hand limit, okay? So let's start. So left hand limit, what is left hand limit? Left hand limit is limit h tends to 0, both LHS and RHS. Okay. Okay, let's see, Sagar, let's see. So I'm finding the LHL, okay, left hand limit. So limit h tends to 0, f of 0 minus h, which is limit h tends to 0, fractional of minus h. Remember, this is what? This is the fractional of negative value, which is just immediate neighborhood of 0. So first of all, tell me what is fractional x? Fractional x is nothing but x minus box of x, right? So this can be written as limit h tends to 0 minus h minus of minus h. Okay. Which is C, which is, this is 0, right? This is 0. And what is this? This is greatest integer function of a very small negative value. This is greatest integer function of a very small negative value. What is this? Greatest integer function of a very small negative value. What is that value? The greatest integer function of minus 0.00001. What is that? Minus 1, right? Minus 1. So what you will get? This is 0. So 0 minus of minus 1, which is 1. So it means left hand limit kya aa raha hai? 1 aa raha hai. Sagar, see, left hand limit is 1. Clear? Now let's find the right hand limit. Right hand limit. Right hand limit means limit h tends to 0, f of 0 plus h, which is limit h tends to 0, fractional of 0 plus h, means limit h tends to 0, fractional of h. So इसको कैसे लिख सकते हैं? This can be written as limit h tends to 0, h minus fractional h. Sorry, h minus box of x, right? h minus box of h. Is this clear? सबसे पहले बताओ, सबको समझ में आ रहा है क्या? So what is this? This is greatest integer function of very, very small positive value, right? Which is, let's say, box of 0.00001, which is 0 only. And this is 0. So 0 minus 0, which is 0. Is this clear? So it means left hand limit and right hand limits are not equal. Clear? Left hand limit and right hand limits are not equal. So it means limit does not exist. Is this clear? Implies left hand limit is not equal to right hand limit. So limit does not exist. Clear? Is this clear, Sagar? Any doubt? And students, see, alternatively, how you can do this. See, this, what is this function? Function is nothing but f of fractional x, right? Everybody knows the graph of fractional x, right? सबको ग्राफ पता है. सेट रिलेशन फंक्शन में हमने पढ़ा था ये. Graph of function is like this, right? Yes or no? This value is 1, right? And this is like this, right? Clear? Okay. As you can say here, see, this is x is equal to 0, right? Now tell me, student, if I approach this function from the left hand side, value of the function is approaching towards 1, right? And if I approach this function from the right hand side, the value of the function is approaching towards 0. So from the graph also you can directly comment that the limit does not exist, because as I approaching the fractional x, as I approaching the x from the left hand side, my value of the function is approaching towards 1. And if I approaching my function from the right hand side, the value of the function is approaching towards 0. Clear, everyone? Is this clear? Tell me quickly, let me know in the chat box. Is this clear? So that's why you can say. So if you know the graph of the function also, then also directly you can say that whether the limit exists or not. Is this clear? Sagar, quickly let me in the chat box. Everyone, quickly let me know. Janvi Balari, Janvi Chitra Durga, Kripa, everyone. Is this clear or not? This concept is clear or not? Quickly let me know, students. Okay, very good, Janvi Balari, very good. Okay. See, that's why whenever there is a fractional x, modulus x, or greatest integer function, we'll try to find the limit separately, left hand side and right hand side separately, and then start commenting on it. Okay, very good, Sagar, very good. Okay. Okay, so that's the note here. What is the note? Note is, in case of function like greatest integer function, fractional x, or modulus function, evaluate left hand limit and right hand limit separately. Okay, left hand limit, right hand limit separately. Otherwise, in case of polynomial upon polynomial, trigonometry upon trigonometry, we can evaluate limit directly using the limit techniques we will be studying from the next class. But this should be clear that in case of greatest integer function, modulus function, okay, or the fractional x, evaluate the left hand limit and right hand limit separately, because most of the student does this mistake. They don't evaluate the left hand limit and right hand limit separately in such function, and they directly give the wrong answer. Okay, from the function itself it should be clear. Like we will do the enough practice that from the question itself we should be able to tell whether we have to find the left hand limit, right hand limit separately or not. But in case of greatest integer, fractional function, or modulus, we for sure we have to find the limit separately, okay, without fail. Clear? But if there is a function like polynomial function, trigonometric function, then there is no need to find the limit LHL, RHL separately. Just directly find the limit using the limit techniques. Okay, it is very, very important. Okay, is this clear, everyone? Any doubt so far? I hope this is clear now. Okay, if it is clear now, let's solve this question now. Okay, see, I'm going to show you in this question that, see, first of all, this is polynomial function, right? This is polynomial function. Okay, so here I'm going to show you that in polynomial function there is no need to find the left hand limit and right hand limit separately. Directly you can find. Okay, so first of all, how we are going to see is limit, method 1, finding the LHL, RHL separately, right? Method 1 क्या है? Finding LHL, RHL separately. Okay, finding LHL and RHL separately. Okay, clear? So सबसे पहले let's start LHL. What is LHL? Value of the function when I approach the function from the left hand side. Fundamental should be clear. Okay, it means limit h tends to, sorry, or you can say that limit limit x tends to 2 minus f of x, which is limit h tends to 0 f of 2 minus h. So now tell me, student, what is the definition of function in the left hand neighborhood of the two? This, right? Right? So it means we will use this definition, limit h tends to 0, 4 minus 2 minus h ka whole square. Clear? Is this clear? Because I am finding the left hand limit. So I am approaching the function from the left hand side. And in the left hand side of 2, the definition of a function is 4 minus x square. So that's why I'm using 4 minus this function. Clear, everyone? Okay. Since it is clear, so now let's start solving it. So what is this? Limit h tends to 0. This is what? 4 minus a minus b ka whole square. A square plus b square minus 2ab. So this is limit h tends to 0. 4 minus h square plus 4h. So 4 and 4 cancel out. We will get limit h tends to 0. 4h minus h square. Clear? Since it is not an indeterminate form, right? So directly now put the h equal to 0. Kitna aega? 4 into 0 minus 0 square, which is 0. So it means left hand limit is 0. It means left hand limit kitna hai? 0. Clear? Now let's find the right hand limit. Okay. RHL. What is RHL? RHL means limit x tends to 2 plus f of x. Means limit h tends to 0 f of 2 plus h. Now I'm approaching the function from the right hand side. So what is the definition in the right neighborhood of the 2? 2x minus 3. So it means limit h tends to 0, 2x minus 3. So 2, replace x with 2 plus h minus 3. So it is limit h tends to 2, 4 plus 2h minus 3, limit h tends to 0, 1 plus 2h. Now put the h equal to 0, what you will get? 1 plus 2 into 0, 1. Clear? So it means right hand limit kitna hai? Yes, very good, Sagar. Right hand limit is 1. So it implies left hand limit is not equal to right hand limit. So limit does not exist. This is the sign for does not exist. Is this clear? Right? So this is I have shown you by finding the left hand limit and right hand limit separately. Yes. Okay. Now, since it is a polynomial function, students, since it is a polynomial function, so I was saying you don't need to find the left hand and right hand limit separately. You can directly find the limit. Okay. So what is the f of x? F of x is 2x minus 3 when x is greater than or equal to 2 and 4 minus x square when x is less than 2. Okay. Okay. So limit x tends to 2 minus f of x means limit x tends to 2 minus what is f of x? 4 minus x square, right? So directly put the x is equal to 2 in it. So you will get 4 minus 2 square, which is 0, right? Now limit x tends to 2 plus f of x, which is limit x tends to 2 plus what is function in the right neighborhood? 2x minus 3. Put the x is equal to 2 in it. 2 into 2 minus 3, 1. So directly you can also find the limit. So this is LHL, this is RHL. So hence limit does not exist. Hence limit does not exist. Is this clear? Is this clear, everyone? Tell me quickly in the chat box how many of you understood. So the idea of the limit you understood, how to find the limit. Tell me, is this clear? Is this clear, everyone, or not? Clear, right? Now you are comfortable in finding the limit, right? Okay. So these are the very small introductory example, okay? Just to get us comfortable with the idea of limit and how to approach the limit, okay? From the next class, we will start our serious discussion on the techniques of finding the limits, okay? So this is the very last example of today's class. Everyone, I'm giving you 30 seconds. Everyone, tell me the answer quickly. See, okay, tell me the answer of the limit. Since it is a modulus function, right? This is a modulus function. So I have told you, find the left hand limit, right hand limit separately and tell me the answer. Everyone, quickly let me know the answer. You have 30 seconds, everyone. You have 30 seconds. Find the left hand limit, right hand limit separately and tell me the answer, everyone. Limit does not exist. Sagar, what is the answer? Like, tell me the right hand limit. What is the right hand limit? And tell me the left hand limit. Okay. What about the other students? Kripa, JNV Balari, JNV Chitra Durga. Everyone. Sagar, what is the right hand limit? LHL and RHL. Okay. LHL is -1 and RHL. Sagar, LHL, not S. LHS means right, left hand side. We say LHL, left hand limit. Okay. Chalo, let's see. Okay, let's see. Okay, very good, Sagar. So now let's check. Since it is a modulus function, student, since it is a modulus function, so we know that we have to find the limit separately, right? Means left hand side, left hand limit and right hand limit we have to find separately. Okay, so left hand limit we are finding. What is left hand limit? Left hand limit is limit h tends to 0 minus f of x, which is limit h tends to 0 minus h tends to 0, mod of 0 minus h upon 0 minus h, right? Which is limit h tends to 0, box of mod of minus h upon minus h. So since, what is box of minus h? H only, right? Upon minus h, which is -1. Clear? So whenever students, whenever we are taking the a minus h, a plus h, here h is positive quantity. Okay, always remember that h is a positive small number. Okay, clear? So left hand limit, how much we are getting? -1. So now let's try finding the right hand limit, RHL. What is RHL? Limit x tends to 0 plus f of x, which is limit x tends to 0 plus h, where h is tending to 0, box mod of 0 plus h divided by 0 plus h, which is limit h tends to 0, mod of h upon h. Since h is already a positive number, so our modulus will open as it is. So it is h upon h, which is 1. Clear? Clearly, left hand limit and right hand limits are not equal. Yes or no? So clearly, LHL is not equal to RHL. So it implies limit does not exist. Clear, everyone? Clear? Okay. And directly also you can say, yeah, right? How can you say directly? See, what is f of x? F of x is nothing but mod x upon x, right? And it is nothing but signum x, right? This is nothing but signum x. What is this? This function is 1 when x is greater than 0. This function is -1 when x is less than 0, right? So you can directly say that x, y on 1 function does not exist. At x is equal to 0, function does not exist, right? So x greater than 0, 1, x less than 0, minus 1, right? So when I'm approaching my function from the left hand side, my value of the function is approaching towards minus 1. And when I'm approaching my function from the right hand side, the value of the function is approaching towards the 1. So directly also you can say that LHL and RHL are not equal. Is this clear, everyone? Is this clear? Tell me quickly in the chat box. How many of you understood? So left hand limit is clear, right hand limit is clear. So from the graph also you can say, you are able to tell how to find the limit, right? Just see, when I approach from the left hand side, where the graph is going. When I approach from the right hand side, where the graph is going. Okay. Thank you. Okay. Okay. If it is clear, okay. So that's all for today, everyone. Okay. That's all for today. So today we have done the introduction of the limit, right? Just how to find the small limit, left hand limit, right hand limit, right? And what are the indeterminate form? What is the difference between not defined and not indeterminate, right? So from the next class, we will be seeing the different method of finding the limits. Okay. So that's all for today, everyone. Thank you, everyone. Take care. We will meet in the next class. Bye, everyone. Take care. Bye. Bye, everyone. Thank you, everyone. We'll see you in the next class.